So our next type of problems are, we have the final couple on our list. We are going to be doing an aquarium for 2 problems. I'm going to do one, have you try another one, and then we have a how many, how much type of problem to finish it off. So when we're doing the aquarium, we have a box-shaped aquarium or square base aquarium. So there's my aquarium. You don't have to draw the picture beautifully, but a square box-shaped aquarium with a square bottom and an open top. The aquarium has to have a volume of 256 cubic feet to hold the water, and we need to figure out the dimensions that will use the least amount of glass. And so I'm going to start with my dimensions on the sides. This is my square base, the square bottom of the aquarium, and the height that has nothing to do with the base. It doesn't say it's a cube, it just says that it is a square base. So the height will not necessarily be the same as the length and the width. But I do know that length times width times height will be the volume. So 256 over x squared becomes my sort of connector. Because I want the least amount of glass, I'm going to be doing surface area, and so I'm going to add together the surface area. So I have a square base, that's an area of x squared, and then I have 4 sides, which all have the dimensions of xy. So the area of the front, the right, the back, and the left are all xy plus xy plus xy plus xy, so 4xy. So then I can rewrite this so I only have one variable, and that's where this guy comes into play, 256 over x squared. And then I'll do a little cleanup before I do my derivative. So that gives me x squared plus 1024 over x, because I'll cancel out an x on each of those. I don't like to do my derivative with that x in the denominator, so I'm going to rewrite that with a negative power, and then I can do my derivative. Set it equal to 0. Because I'm solving here, it's easier to take a derivative with a negative power, but it's much easier to solve. So these are equivalent statements. I just put it in the denominator in order to solve this, which gives me 1024 over x squared equals 2x. I'll multiply the x squared out, divide by the 2, and then I can finish solving by taking the cube root. So the cube root of 512 gives me an x value of 8. I want to do my prime chart, double check and make sure that that is in fact a min. And if I plug in something like 0 into my derivative, I can plug it in here. I can't plug in 0 because that won't work, so I'll plug in 1. That gives me a negative value, and then I'll plug in something like 9 in here, and when I plug that in there, I'll get a positive value. So decrease to increase it is a min. So my base has a dimension of 8 and 8, and now I need to find the y, and y is 256 over 8 squared. When I do that math, I should end up with 4. So I need to find the dimensions to create the least amount of glass. That would give me 8 feet by 8 feet by 4 feet. Problem number 13 is very similar, and so what I'd like you to do is to pause the video and see if you can go through and set that up. It's the same type of problem. Only thing that changes is instead of 256, we have a volume of 108 cubic feet. So again, pause the video, go ahead and do problem number 13, and then we'll take a look at that shortly. All right, welcome back. If done correctly, your problem number 13 You should have gotten 6 by 6 by 3. Pause the video, check the work, see if you can find an error if you need to on your end. Otherwise, we'll move on to problem number 14.